So it's kind of saying that it's got the graph and it shows basically just the path of an object.
Right.
So it launches here, comes down and lands out here. It's not very good, but it says you got the peak and each side is symmetric. So everything on this side will just be the same on this side, just kind of reversed. So then how do the speeds, so let's see, V naught, V1, and V2, okay. So V naught, that's the speed right before it leaves, or as it's being launched. And V1, and V2. So V1 is its speed at the peak, and then V2 is its speed as it's heading back down, like right before it hits the ground. So it's asking how all of these compare to each other.
Okay. So it's saying that V naught is greater than V1? The case, or?
Yeah, it would be, because if you, if you break it down, V naught has an X and a Y, right?
Right.
And what happens to the Y when you reach the peak?
It levels off.
Yeah, so it goes down to 0 and you end up with a V1. Since the X velocity doesn't change, V1 will actually just be the X portion of this.
Okay.
So yeah, V naught would be greater than V1.
And V1 would be greater than V2?
Is it just asking about like the magnitudes of them?
Yeah.
Okay, so the speeds.
Speeds. Times it, and also times 0, times 1, and T2.
Okay.
Pair.
Well, so we know that the X portion of this looks like that, and we said that this would be equal to that, because what happens is the Y decelerates until it hits 0.
You're right.
So you've just got a 0 Y, and all of it is the X. But over here, has your X velocity changed at all?
No.
No, so it'd still be the same length as this one, and this one. But now you have a Y velocity going this way. So if this is the X component and this is the X component, and they're both the same as this one, will the V1 be larger or smaller than V2?
Smaller.
Yeah. So V1 is the smallest of these three.
Okay. Would it? It talks about like 0 when it gets down to 0.
Mm-hmm. So you've got like options
So
like
what-
this.
So what point, like when it hit that point at 0, by V2 or?
As far as what it's saying in the answers.
Yeah.
Yeah, what it's saying is, is the speed greater than 0? So at any of these 3 points, does it have 0 speed?
No.
No, because it's always moving.
Right.
So even if it's moving like negatively, it still has a speed. So all of them are greater than 0. So you know that 0 is going to be the smallest. Then we said that V1 was smaller than either of these two. Oh, I guess they have it written the other way, don't they? So they have 0 over here, smaller than V1.
These are smaller than V1.
Right. Yeah, so we said that all of these are greater than 0.
Right.
So that would be 0 would be the smallest value.
Yeah.
And then V1 is smaller than both of these because it's just the X component.
Would those be equal?
Yeah.
Okay.
Yeah, it's because it's the same, like,
V naught, V2 be equal, and then V1 would be less than both of those.
right. So that it would go like this. whoops, is greater than V1 is greater than 0. It's just that idea of like if you take a ball and throw it up into the air, it'll come back and hit your hand at the same speed that you threw it. It's just in this case you're throwing it sideways as well, but the y velocity is the only thing that changes.
Okay.
So what they're kind of getting at is that if you're on just flat level ground and you shoot a ball off at some angle with a certain speed, then it'll hit the ground at the other end with the same speed and the same angle.
Gotcha. So, okay.
So now it's saying you take the same thing, but you make V naught 30
30 meters per second.
and 60 degrees.
Yeah.
Okay.
So we're trying to find is it the x component of V naught?
Yeah, is it the X or is it both?
It's both. Oh, it's Vx, V naught x and V naught y.
Yeah. So that's kind of like, if we just move it over here, this is your 30 meters per second, 60-degree angle. And V naught X is here, V naught Y.
Okay.
It's just asking what these are equal to.
Okay. So would that be, the Vy be or the 30 meters per second, would that be the hypotenuse?
Mm-hmm.